Assalamu alaikum, gentlemen. How are you, students? Okay, okay. So today we are going to discuss about shift registers. Um, Today the lesson is shift register. Okay. Okay. What is shift register? According to the definition, shift register is a circuit which is constructed from basic flip-flops. So it means that shift register is made up of flip-flops. We already studied basic flip-flops last week and before last week also. We studied SR flip-flop, JK flip-flop, and D flip-flop also. Shift register is basically made from either D type or JK type. Okay. So what are the use of the shift register, or what are the two important properties of the shift register is they can store a binary number. So shift register can able to store a binary number, and the number can be shifted within the register. Okay, so these are the two important properties. One is they can store a binary number, and second one is the number can be shifted within the register. Shifted means moving. Okay, we can move the number from one register to another register. We will see in detail this one later. So now see the next slide. So here draw the circuit of a 3-bit serial in serial out shift register using D flip-flop. Before that, what is this serial in serial out is there are 4 type of shift register. What are they? Serial in, serial out, that is means serial in, serial out. Okay, then serial in, parallel out, then parallel in, parallel out, okay, and parallel in, serial out. So these are the 4 type of shift register. Once again, serial in, serial out, then parallel in, serial out, and here serial in, parallel out, finally parallel in, parallel out. So what is this one? First we will see one by one here. What is the serial in, serial out? That means this is a shift register, the data entering serially, therefore it is called serial in, and also the data is leaving also serially, therefore it is called data out. So the data enter serially. Serially means what? One by one. So entering, for example, if there are bits, say 1010, so this bits 1010 enter one by one, and leaving also one by one. So this is a slow shift register. This type is very slow because entering and leaving serially, therefore it is slow. Now this is for what? This is right direction, and this is both are same type. This is also serial in, serial out, as well as this is also serial in, serial out. So what is the difference between this one is the direction, the orientation or the direction. So here the direction is left to right, and here the direction is right to left. Okay, so here that means here the data entering from left side and leaving right side, but here the data entering right side and leaving it left side. Okay, now second type. So this is first type. First type, subdivisions. There are 2 subdivisions, A and B. Now regarding the second type, parallel in and serial out. So that means, see here the data is entering parallel. What is meant by parallel? Parallel means simultaneously. Okay, not one by one, together or simultaneously. Okay, but how this is moving out, leaving, it is serially. So serially. So parallel in, serial out. Okay, so that means for example, if the bit is 1010, so all these bits, any bit take 1010, any 4 bit. So this is 4-bit shift register. So it is entering parallelly, same time it is entering, as well as but at the same time leaving serially, one by one it will leave serially. Now third type is serial in, parallel out. That means the data entering one by one and the data leaving parallelly. Okay, parallel, simultaneously. So these two are exactly opposite to each other. See this one, I mean type 2 and type 3 are exactly opposite to each other. See here, parallel entry, and here parallel out. Here parallel in and here parallel out. But here serial out, but here it is serial in. Okay. So these two are exactly opposite to each other. Finally, both are parallel. Entering parallel and leaving also parallel. So this should be very fast because entering also very fast. Simultaneously entering and synchronously or simultaneously entering and leaving out also simultaneously. So could be this is the fast shift register. Now rotate right and rotate left also. The data can be rotate right direction, rotation also possible, and in the left direction also possible. So these are the type of shift registers. Okay, now go here. See here. Now how to draw the shift register. So draw the 3-bit shift register. First we will see serial in, serial out. Serial in, serial out shift register using D flip-flop. We already studied that the shift register can be made up of either JK or D type flip-flop, but now we are studying about a D type flip-flop. I already teach you what is D type flip-flop. D type flip-flop, it is like a buffer. Okay, so what is the truth table of D flip-flop? Yes, if the input is 1, output is 1. If the input is 0, output is 0, because it is exactly like a buffer. So 3-bit shift register. So here there are 3 flip-flops, basically D flip-flop, and clock is simultaneous clock. Okay, here the clock applied parallel. Okay, and the data input applied serially. Okay, and what is the arrangement of this one means? See, this is the input data and this output. So the first output is connected to the second input, and second output is connected to third input, and the third output is leaving. Third output is leaving. So this is the arrangement of shift register, and preset should be high. Okay, clear. If you want to make all the shift register 0, so using the clear input, you will make all the shift register containing 0. If you want to make all preset, then you can use the preset signal. This is data input and this is data output. So this is serial in, serial out shift register. Assume that how, for example, 101, how it is stored. The first one, assume that this is 101. So the first 1 will come here. Then this 1 will shift here, the 0 will come. Then this 1 shift here, 0 here, and the third one is come here. And leaving also serially. We will see later these things. Now see here, serial in, serial out shift register. Before we studied this is 3-bit, and here what is the difference between the two is very simple. This is 3-bit shift register and this one is 4-bit shift register. So 4 flip-flop, F of 0, F of 1, F of 2 and F of 3. Okay, and the clock, simultaneous clock. So serial data input and serial data output, and see here the first flip-flop output connected here, second flip as a input of second flip-flop, second output connected to the input of third one, and third output connected to the input of the fourth one. Okay, serial connection. Okay, so serial in and serial out. Okay, so this is 4-bit. So this is the draw of 4-bit shift register. Okay, now see how the arrangement of data. Assume that the data is 1010. Okay, that means the data given is 1010. The data given is 1010. How it is moving? So before that, please carefully understand that this is F of 0, F of 1, F of 2, F of 3. F of 0 is the first one, F of 1 second one, F of 2 third one, and F of 3 fourth one. See the table here. The data is 1010. Okay, so initially all the things will be initially shift register, everything will be 0. Now during the application of first clock pulse, okay, the data 1010, so the 0 will come here. 1010, the 0 will come here. Then what will happen is this 0 is shifted here, second clock pulse, this 0 is shifted here, and the next one is coming, second clock pulse. Third clock pulse, this 0 is shifted here, and this 1 is shifted here, and the third bit is entering here. During the fourth clock pulse, this 0 is shifted here, and this 1 is shifted here, and this 0 is shifted here, and the 1 is entering. So now after the fourth clock pulse, the shift register contain the data 1010. So since it is 4-bit, it need 4 clock pulse. The data 4-bit data 1010 is now in the shift register. Okay, assume that the data is 1010. So how many clock pulse require? At the end of the fourth clock pulse, the data will go 1010 because it is serial in. But if it is parallel in, no need for 4 clock pulses. Only 1 clock pulse it will enter simultaneously. But here it is the data entering one by one. That is why it requires 4 clock pulses. Okay, so at the end of the fourth clock pulse, this shift register contain 1010. Now how it is leaving? This table is showing that how it is leaving. So how it is leaving means during the fifth clock pulse, what will happen is that 0 will going out. Okay, that 0 will going out. So what is happening is, see, this is the data 1010. So this 0 will be coming out. So what will happen? This coming out, then this 101 will appear here, 101. Okay, during the sixth clock pulse, what will happen is the next data, this one will move out, this one will move out. So what will happen is the 0010. Okay, now during the seventh clock pulse, this again this 0 is going out, so the only one. During eighth clock pulse, all 1010 going out of the register. So initially the 1010, now it is going out one by one. So first this 0 is going. If the 0 is going, then what will happen? 101. See, 101. Now if this is this 1 is going, what will happen? 10. So here it is 10. Now now what will happen is here 10. Now it is only 1. See here only 1. Now everything is going out. So all the 1010 going out. So the shift register now contains 0000. Completely reset, because this 1010 is going out serially. Okay, first this 0 is going out, then this 1 going out, then this 0 going out, then this 1 going out. So after the 8th clock pulse, so at the end of the 7th clock pulse, everything is going. At the end of the 8th clock pulse, the shift register is completely reset. Okay. Now see here, this is the waveform. So here, how the question, so this is very important. So how the question coming is, they are giving the shift register. For example, here how the question is, this is how many bit? 1, 2, 3, 4, 5. 5-bit shift register. Type is serial in and serial out. This is a 5-bit shift register. So maybe the question is coming like this: draw the 5-bit shift register. So you have to draw this shift register, and the clock will be given, data will be given. You have to draw all the output. So how many output here? Q0 first output, Q1 second output, Q2 third output, Q3 fourth output, and Q4 fifth, 5 output. So here 5 output: Q0, Q1, Q2, Q3 and Q4. So 1, 2, 3, 4, 5. Since it is 5 bits, so we have 5 output. Okay. Now you must know how to draw these 5 outputs. Okay, very simple. Let me explain. So here the clock, how many pulse clock? 1, 2, 3, 4, 5. Because it is 5, so we need 5 clock applied simultaneously. So it need 5 clock pulses. Okay. So this is the data. So we know this is the data. Data is given, clock will be given. So first output Q0. So this is just D flip-flop. This is according to D flip-flop. I already explained D flip-flop. How D flip-flop is working? D flip-flop. So start from 0. I already told that. You remember that this is the first checkpoint, second checkpoint, third, fourth, fifth. So first checkpoint, what is the data? 1. Since it is a buffer, so what is the output? 1. Okay, so output is 1 here. Now second checkpoint, see the second checkpoint here, input is 1, so the output is 1. And here between the checkpoints, nothing will change. Okay, because it is a memory, so it store the memory. Now third checkpoint, input is 0, so the output is 0. Okay, then the fourth checkpoint, input is 1, so the output is 1, and fifth checkpoint, input is 0, output is 0. So what is this waveform? This is exactly like D flip-flop output. Okay, this one we already studied before, how to draw the output of the D flip-flop. Repeating again, very important. If you know this one, all other things are very easy. Shifting is very easy. So you just know how to draw this one like a buffer. Assume that this is a buffer. Exactly, it is a buffer. So there are 5 checkpoints. The first checkpoint, the input is 1, so draw 1. Second checkpoint, input is 1, so draw 1. Third checkpoint, input is 0, so it will be 0. And fourth checkpoint, input is 1, it will be 1. Fifth checkpoint, input is 0, it is 0. So this is the output. Now just shifting only, just 1 bit shift. See here, see this is Q0, now Q1, see this one is shifting 1 bit. So that means, so see this shape, okay, this is 1. So this is 1 bit shift, okay. Assume that somebody pushing, assume that somebody is pushing this one bit from left to right, this direction, okay, like this direction, okay. Not from, it is from left to right, the pushing from, assume that this is pushing from left to right, okay. So just if you assume that if you push this one bit, so if you push, so what will happen, so this is exactly replicating. See here, this one, now how many here, 2 pulses, so here 2 pulses. Now there is a low here, okay. Then there is a high here, okay. What happens, this one, it is already stored in the next bit, okay, because we have to stop here, okay. This is already gone. Now again 1 bit shift, so what will happen, so see this is, assume that, so here one push, 1 bit push, so here it is low, again low, and see this is high, so this is high, too high, so this is high, and again low, okay, again low, and so on. But no need to draw everything. Now see here another push, so assume that, so what will happen, initially everything 0, now see this is 2 ones, here 2 ones, so 2 ones, okay. Now see here again pushing, so see this is initially low, now see this one pushing here, okay, so 1. So finally, so what is the data here, this is, see the data 11010, see here 11010, the data bit stored after 5 clock pulses, this 11010, see here in the shift register 11010 will be stored after 5 clock pulses. This number 11010 is stored, 11010 is stored, okay. So this is how it is working. I will explain in detail, inshallah, next week. I will explain, I will conduct the Blackboard lesson class using Ultra Collaborate. Then I will talk to you, and I will interact with you, and you can explain also, how this is working also, okay. Now this one, so this is again serial in, serial out shift register. So this is the data input and clock, this is serial in, parallel out, see here simultaneously coming, okay, parallel out, okay. So serial in and parallel out. Now this is parallel in and parallel out. So see the input, parallel input, and this is parallel output, okay. D0, D1, D2, D3 parallel input, Q0, Q1, Q2, Q3 parallel output, okay. This one is input is serial but output is parallel, okay. And this one, okay. Okay, Shabab, this is about shift register. We will, inshallah, next week I will conduct the, as usual, Monday, I will conduct one session on Monday 9-10, another session on Thursday 7-8. I will make announcement for this one, and we will discuss about this one. Okay, thank you for listening. Good luck for you.